Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Astro Mechanica. So let's dive deep into it. So what exactly is the problem that they are trying to solve that they have to make a new company out of it? Well, reality is flying has not changed much. Basically, if you go back to 1960, remove the electronics and remove the fuel efficiency, inherently core is same. Exactly same. Almost nothing has changed. So jet engine, the core of the flying system that we use, is very good at limited range. That's the problem. Meaning, if you want to make a jet engine that is very smooth, very efficient at Mach 2, we got this. If you want to make a jet engine that is very smooth, very efficient at Mach 3, we got this. If you want to make a jet engine for 700, we good, we got this. But there lies the core problem. Meaning, we do not have one engine that can work in all these three systems. Basically, you must have thought of it, right? If Concorde could not fly supersonic at a populated place, why not be subsonic, and then once you go above basically sea, go supersonic? Yeah, it would have run out of fuel if it had done that. Yeah, it's a weird thing. Basically, you may think, oh, driving slow will save fuel. No. Jet engine is such a weird device that it only has a very sweet spot. Even these jumbo jet systems, they love to their speed, their cruising altitude is set in the design documentation and done. They're good. The moment you want to do slower, it will burn more fuel. The moment you want to fly faster, again, it can't go much faster, but it will. If you try to do that, it will burn too much fuel. And heck, it burns more fuel when it's a taxiway. Like if you calculate how much fuel is burning per kilometer, it is burning more fuel when it's on the ground. So that's the core problem. So we have turbofan for low speed, subsonic. We have turbojet for Mach 2 kind of speed, and we have ramjet for Mach 3 plus. So it's basically fundamentally all these things are wasteful as hell the moment you go out of their sweet spot. So there lies the core problem. So what we want to do is build one engine that can operate in all these three regimes, basically subsonic, Mach 2, Mach 3. So that's the whole point. To give you a context how big of a deal we are talking about, this puppy used to burn 2 tons of fuel just to start up taxi and all that. 2 tons of fuel, poof, gone. And that's why people could not bring it back. It's just too goddamn expensive. And again, that's another reason why I cannot just go super subsonic when it's going above people. It will run out of fuel. So fundamentally, that's an issue. And again, even these planes, especially the twin body that is super popular right now, they hate it, the fact that they are burning more fuel proportionately when they are taxiing. Meaning they could be burning as high as 15 to 20% of fuel, especially for short haul flights in taxiing rather than the actual flying. So that is a fundamental issue that we are trying to solve. We have the technology, we just don't have the efficiency. So what is the current way of dealing with this thing? Well, the current way of dealing with this thing is to understand the problem. The problem is the RPM, meaning if you want to have a very high compressed airflow and you want to dump a lot of fuel into it, it will create a certain amount of high pressure and high flow rate. Now, there are certain things you can do in geometry to make sure the RPM is matched, but there is an upper limit to that. Meaning you will reach a point where it's like, bro, you have to increase the RPM. So core of the jet engine wants to go super fast, and you will have the fan that is pushing the most amount of air at subsonic speed. It wants to be slow, because otherwise the tip velocity will be supersonic and you will lose all your efficiency in sonic drag. So how do you solve with that? Well, that's the core problem, the RPM. So we solve it with 2 methods. One is gearbox. Basically, the core rotates at however speed it needs, let's say 7 to 10,000 RPM, and the fan rotates at half that RPM. So that's one way of solving it. I have not seen great success in that regard, but it is one way. Second way, my personal favorite, is multi-spool technology, meaning each shaft has a coaxial shaft inside it. Basically, you will have one huge shaft that is the fan blade compared to the last stage of turbines. And then on top of that big shaft, you will have another smaller shaft, that is the yellow shaft system, that will have another turbine locked to another compressor. And the red one would be very high RPM, very high power. That would be, so all three could be rotating at different RPM. So you have 10,000, 5,000, 3,000 RPM. So that way you can get the most efficient optimum utilization. This is from Airbus A380. Twin spool is quite common in almost all fighter jets and even in basically passenger airlines, although triple spools are quite rare. And I do not think there is any reason to go above 3. It becomes too much complications, but this is the best I have seen. This method is far more prevalent worldwide, especially twin spool. So that is one way we can handle the situation. And then you have, what do you do when you need to go really, really fast, like SR-71 fast? Well, you bypass that thing, because again, if you try to force everything through, the drag of the frontal area itself would be the limiting factor. So they take air directly out of compressor. They're like, don't compress it. We are moving fast enough. It's compressed enough. They just have a pipe, like three pipe this side, three pipe that side. They just open it, and that directly dumped into afterburner section. So you have compressed air because of the front ramming effect, and then voila, you dump it into the fuel section and boosh. So that way you can go very high speed ramjet. And some amount of this sort of technology was utilized in different way in Concorde. The pylons that you see where the engines were, they had a adjustable geometry, because you have to understand, jet engine does not like high supersonic air. If you send supersonic air, jet engine will be destroyed. So how the Concorde did that? Well, whenever you see fighter jet, they have like nacelle, so to say, air nacelle. That's the design of it. So they have vanes in that, and that vane creates shockwave. Shockwave acts like a transformer. Basically, you have low pressure, high velocity air, and that gets compressed, inverted. Basically, you go from high velocity to low velocity, low pressure to high pressure. It's almost like a transformer. And air compressors love high pressure air, not high velocity, high pressure. And that's how the engine was. Basically, from engine's point of view, it never went into supersonic speed, because again, this kept adjusting. The shockwave was always adjusted to a point where it's like smooth. And once it reached to that, the geometry was super optimum. At that point, everything is fine. Same with this, that nose cone that was used to adjust itself. So make sure the shock creation is perfect. And once you have that, everything is smooth. But there lies the core problem. These geometry can only be optimized for one thing. You cannot optimize it where it's like, oh, Mach 1 is the same efficiency as Mach 2. It will be designed in such a way that Mach 2 would be the most efficient, but Mach 1 would be like, just go through Mach 1 as quickly as possible. Same with SR-71. Take off as little fuel as possible, go to high altitude, get aerial refuel, then yeet out of there. So again, you would be shocked how quickly they will lose range if they are not at super optimum speed. So there lies that. And what do we do to improve this further? Well, in the compression section, we have vanes. Those vanes have adjustability now. Now, as in like 1960, 70, they started to happen in commercial airlines. And that guide vanes allows the compressor to work at different altitude air. So sea level to 30,000 feet is like, I got you, fam. So you will not have compressor stall unless something bad has happened. So these are the current tools we utilize in jet to do our best. Basically, these are the tools. But again, as you can understand, if we have been doing all these from 1950s and 60s, they have limitation. So Astro Mechanica is like, hey, what if we disconnect, basically that metal shaft we disconnected. You have the turbine running a generator. Generator gives you electrical wire. That electrical wire drives the motor. That motor drives the compressor. At that point in time, the RPM becomes completely independent, meaning at low altitude, you need very low RPM, no problem, you got this. At very high altitude, you do not need very high speed, you got that. You can do all of that variability without too much issue. So I got that. And then question becomes, okay, how the heck you gonna drive the motor? You are talking about megawatt class power. No battery is powerful enough. Well, we'll go back to the same 1 century old technology like diesel hybrid. Basically, series hybrid train. You have a fuel that goes through a jet engine, converted into electricity. That electricity drives the compressor. So, and fuel would, instead of using JP1, jet propellant 1, they will be utilizing liquid methane or LNG. They do not need as purity as like liquid methane. They just need purity of LNG. LNG is like, there is some amount of ethane and propane into it. Ethane and butane is mixed there. But when you talk about like rocket grade CH4, liquid CH4, that's pure, almost like 99% CH4. So why would you want to do that? Well, A, is cheaper. It's ironically cheaper. Basically, LNG tankers, if you directly siphon from them, it's cheaper. And again, even if you buy it, it's cheaper. And it also has low CO2 footprint. That's also another good part. But penalty is cryogenics. It's called. So the power plant design would be two jet system, meaning you have two systems working as one. So you will have one jet that is a power plant. It's just taking the air in, converting it, basically driving the system to power the generator unit. Generator unit will provide the power to propulsion unit. Now, propulsion unit is not just propulsion unit. It's not just a fan, electric fan. It's not electrically ducted fan. Even though it will act as one, that's just one mode of operation. So it will, mode one is just a electrically ducted fan, just driven by a very high power generator. Then it will start to dump fuel into that system. Basically, the moment you want to go at higher speed, it will start to dump fuel into there, basically methane, and it becomes almost like a jet engine. At that point in time, instead of turbofan, it's a turbojet engine. And once you go at certain high speed, it can just shut off the compressor, because again, the forward momentum is high enough where the compression effect is done by default. You do not need to run compressor, or heck, you can even run compressor in a little bit of reverse, so basically acts as a generator and leach power from that for all your auxiliary need. So that can be done in principle. So that's what they're going to do. And the reason why would you want to do this is because, again, it's 100% useless if you want to drive at subsonic speed. At that point, just use that what you have for Airbus A380. That's the most efficient system. But if you want an engine that can work at subsonic, supersonic, and high supersonic, yeah, for that point, you need this. Because this engine gives you one ability. Basically, let's just say you are in a country that allows supersonic speed, but only to Mach 1.2. Because at that point, the sonic boom does not travel downwards if you have good aerodynamics design in your system. That's what boom aerosonic is trying to do. So let's say you can travel there. But here's it. Concorde could not do that. Concorde is like, bro, I have to travel at Mach 2, otherwise my efficiency is gone. That's like, bro, I got you. I got you. I got you, fam. I got you. And then you are like at sea. It's like, let's go. At that point in time, you go into RAM mode and just yeet out of there. And then when you are coming at to land, you're like, hey, let's cool down, bro. And it's like, Concorde hated that. SR-71 hated that. This puppy's like, I got you, fam. I got you. Relax. We got the RPM, man. Relax. So that's why decoupling these two things, and at higher velocity, this becomes the primary mode of propulsion. It's actually viable where you can switch from fan mode to jet mode to RAM mode. So all these three modes become possible where you can have literally something like SR-71 or SR-72, where you have the ability to like, hey, I can take off efficiently, I can cruise efficiently, I can go Mach 1.2 efficiently, Mach 3 efficiently. So that's the whole point. And because of the low cost of CH4 or liquid methane or LNG, it's actually viable, because you have to understand SR-71 required a special fuel because it used to overheat a lot. That special fuels were so expensive. It was like back in that time, yeah, satellites are cheaper. Not even joking, satellites became cheaper. So this is what they are trying to do. And that's why it's interesting. Again, if somebody's like, okay, what if we only operated in subsonic regime? Just use a normal system. Now, what are the challenges they are facing? Well, electric motor and generator is not as lightweight as a steel shaft. Steel shaft directly couples the booster part of it to the compressor part. Compressor and turbine are in one shaft. It's as light as it can be. You cannot beat that power to weight ratio. So there lies the core problem. The task of reducing the weight. We have made amazing progress in motor density, but not there yet. It is still unsolved. And again, they are very honest about it. It's like, if we just did it right now, it would be like, there is no point, because all the energy savings you are getting, you will lose because of the high weight. So that part is not solved yet. Can it be done? In principle, yes, but I do not know you can do that without superconductor. The superconductor generator unit is utilized in 6th generator fighter that is being worked by Rolls-Royce for UK government. That is 2 megawatt powerful and very lightweight. You can actually carry it as like this way, 2 megawatt. But again, that's cryogenic. I do not know whether you can do this without cryogenic or not. And again, if they wanted to do cryogenic, the fact that you could do cryogenics with liquid nitrogen and liquid methane is lower temperature than liquid nitrogen, it may be viable. Not impossible, but not cheap, definitely. So that part still to be solved. Another aspect is jet engine based generator that you are utilizing. It's still a generator, normal jet engine. So you have all the flaws. Basically, you still have to figure out how the heck you make sure that part is efficient, because if it's not efficient, everything else becomes more inefficient downstream. So how the heck you solve its limitation? It's like, how the heck you're going to have a duct that does everything, and how the heck you're going to have a compressor vanes and all the things that need it. Again, it's not unsolvable. It's just that it may reduce your efficiency compared to like what you were dreaming versus what you are actually getting. And liquid methane is not cool. It's freaking cold. It's minus 162 degrees Celsius, meaning you cannot use your wing tanks. And again, maybe you could do it, but it would be ludicrously heavy in terms of insulation. So it's not very, what you call, just plug and play as they were talking about. And in terms of their whole timeline, is just tech bro vibe out of it. Like nothing logical, is just tech bro, man. It's like, they're going to have supersonic flight demonstration in 2026. I'm like, really? The Ian, basically the CEO himself, will fly supersonic at 2029. I'm like, really? And you're going to have passenger supersonic flight being beginning 2034. I'm like, this person has never ever studied the timeline of civilian aviation. Let that be clear. Fighter jets, private system, I can trust all of that. The moment you said civilian in 2034, I'm like, yeah, lol. That's tech, bro. Because here's the, this is the penalty right now we deal with when jet engine have to be fired for taxiing purposes. So you have tug, pilot, walking wings, so many things have to be done safely in order to taxi the goddamn plane. So companies were working on it for 20 years to put motor into the nose wheel. And because again, development in motor and all that. And again, it could have been done 20 years ago. I have linked the video down below of 2005. But again, right now it's super small. It's like almost a retrofit kit now. It's that small. And it will be directly driven by APU. So you do not even need like giant battery. So instead of this many steps, you're going to have that many steps. What does this mean? This simply means almost instead of doing 2 short hops a day, you can do 3 short hops. And instead of like having the engine, again, short hop flights are really bad for jet engine because again, they have to go through that dirty air so often and taxiing so often. Their percentage is much larger. So basically Airbus A380 going from like Atlantic kind of flight, it will be only basically taxiing for very short duration. But compare that to normal flights that we are doing nowadays, it's like much larger percent of fuel is burnt. And you're like, wouldn't that add weight? Barely 200 kilos. So it's not that high of a weight. And not to mention, say, just the engine maintenance cost, shut up, take money. Just the time save, shut up, take money. And heck, there are certain methods there you can, because again, jet engine is off, you can literally move the jet bridges both sides, front and back. And you can just deboard people quickly. That should have happened in 2021. Has not happened yet. There is a very good chance you may be watching this video in the future and then you're like, oh, now I have seen 1 or 2 companies trying that. So yeah, we have not even Wi-Fi as a default in all planes yet, but you're like, we're gonna just have this. I'm like, no. We have been working to add motor for more than 20 years and you're gonna like, oh, we're gonna switch everything. It might take that much long just to have LNG infrastructure in every airport. So yeah, like, no, that the challenge is, but like the timeline was like lol. The timeline was like no. You were just like timeline literally felt like you assume that investors are dumb or investors are actually that dumb that they actually believe that. So I'm like, So what can we expect in the future? Well, this is very clear. Switching from JP1 to LNG is not cheap. Not because the basically, you know, LNG is not cheap. LNG is cheap. Is that all the money you saved in the low cost you will lose in handling? Cryogenic liquid handling is not something that you can just like lol it. And it's not even liquid nitrogen. It's a freaking liquid methane. Ludicrously colder. So it's not that efficient. Another aspect is, there is a certain law of physics that says drag is directly proportional to the speed. If you're traveling at subsonic, your drag penalty would be less compared to traveling at Mach 3. So how many people can afford Mach 3 penalty? Very few people can afford that. So that creates an issue where for public, not ultra rich, not uber rich, for public, it's not kiss enough. Basically, keep it simple silly. For common passenger, low cost passenger airlines, it's far more effective to have like wheel motors, good Wi-Fi, good bathrooms, and rather than like having Mach 3 capabilities, which mind you may not allow to be traveled everywhere. So for most public use case scenario, it does not make sense to go through that much hassle. Although, let that be very clear, while it has almost negligible potential in commercial airlines, like there are a lot of people who are orgasming right now, which is Air Force. Air Force can afford it. And I mean, multiple countries Air Force can afford it. And they will be happy to pay for SR-72. Basically, if you want to make Dark Star, if you make it conventional, basically upgraded version of SR-71, while having an independent ramjet rather than pipes, you have an independent ramjet. It is okay, but having this technology where you have decoupling of that and where you have the benefit of it's like, hey, efficient at while you are refueling, that directly translates to much longer, much slower speed surveillance. That's like shut up, take money. And when you really somebody's like, hey, I got your ass, missile up your ass, you're like, okay, bye. Even if you can only reach Mach 4.5, almost no missile can hit you. And be mindful, by the time SR-71 was used, there were missiles, surface-to-air missiles that were Mach 4 capable. It's just that if you are already high enough, already traveling at Mach 3, or igniting Mach 3 the moment you detect radar lock, yeah, that catch-up is not happening that easily. So the closest missile, I think, got to 1 kilometer of SR-71. So fundamentally, all military airlines are like, come on, man, make this technology. I can easily see them if they start to go bankrupt. Air Force would be like, hey, bro, don't worry about it. We got you, fam. So I can easily see that. And why can they do it? Well, they are already used to cryogenics. To give you an idea, all fighter jets have liquid oxygen. I did not even knew this. Like I used to think they have compressed oxygen. Used to, but now almost all of them have switched to liquid oxygen. And again, I already talked about having cryogenic motor generator unit in 6th generation fighter. So cryogenic is like, bro, we've been doing this from like, first ICBMs, they were cryogenic. So we got this, we're good. And logistics, all the liquid LNG, again, it's same complexity as having fancy jet fuel for these puppies. And they carry nuclear warheads. They're good. Logistics, they're good. They got it. So is it small enough to be a missile? Not really. Is it small enough and efficient enough to be viable as a SR-72? Undeniably so. Like shut up, take money kind of so. So I can see a lot of use case, a lot of companies, countries pouring money into this. But in terms of like a civilian airlines, likelihood is like, no. Air Force, so SR-72 happening soon, maybe 2045? So this was my presentation on this electric-powered, methane-fueled jet engine. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.